5.7. Solving inequalities using adding and subtracting. So remember to write in today's date and don't forget to put your name. Mine is Tara. So solving inequalities uses the exact same process as solving equations, except you need to show your solutions on a number line. No longer can we just say x equals 2. Okay? We know that if I say x equals 2, I would write on my number line, because it extends in both directions, a dot at 2. Done. Okay? But when we say something like x is greater than or equal to 2, what we need to do is we need to show that number line. Okay? Put our 2 there, and our number line extending in both directions. Put a solid dot because it's greater than or equal to. And then remember what we need to do. We need to write our full solution, which is like this. Okay, so x can be 10, x can be 5, x can be 20,000, but x cannot equal 1, and x cannot equal negative 52. So there are lots of things, but let's just boil it down to 2, just reminding ourselves of the way that we solve for equations. The same thing applies. I'm going to say use, let's write that down correctly, use opposite bedmass. Okay, what I mean by that is, in general, we use adding and subtracting before we get to the division and multiplication. Now, I'm going to say that very loosely. I'm going to say generally, because we have seen in some cases it makes more sense to start out with the multiplying or starting out with the dividing. But in general, we use opposite bedmass, so using adding and subtracting first to isolate the variable. And that is a perfect segue into number 2, which is isolate variable. To one side. Whenever you see solving, that is the name of the game. We want to see what that x equals. We want to isolate it. So, example number 1, solve. And actually, example number 1 extends for 4 examples, and then we finish off with just a quick little example there. So let's just go in here. So x plus negative 14 is is less than 1. What I'm going to do is I'm going to fix up this complication here. I see a positive and negative butted up against each other. Remember our rules. I think that they're still up on the board. Whenever you have a positive beside a negative, it becomes negative. So x minus 14 is less than 1. So we're going to pretend that this right here is our equal sign. I'm just going to write it in again. Okay. What I need to do to both sides of the inequality, so on the left-hand side of the inequality and the right-hand side of the inequality, we need to add 14 because it says x subtracted 14. Okay, so we're going to do the opposite sign. So we're going to add 14 to make negative 14 plus 14, 0. And I need to add 14 to the side too. And again, this is just an intermediary step. I'm expecting that you don't have to write in the extra little reminders to yourself. So I'm going to say x is less than 1 plus 14, which is 15. Done. That's fabulous. Now we need to also have our number line, which extends to infinity in both directions. I'm going to put my my important number here is 15. And I'm going to use an open dot because it's not greater than or equal to. So I'm going to say open. And I'm saying x is less than 15. So x can be 14. Oh, yes, it can. X can be 0. Oh, yes, it can. But x cannot equal 24. No. So my my solution goes like this. Open dot going off to the left. Fabulous. Now the next example is very similar to it. The only thing that we notice is this is a negative 14 and this is a positive 21. So guess what we're going to do to both sides? I think you know. Just preemptively, I'm going to write my sign just so that I keep it in the same direction. The next lesson is going to get a little trippy, a little trippy with the signs, a little trickier, but that's in next lesson. So y plus 21 is greater than or equal to 7. So the name of the game is isolation of the variable. So I need to get the y all by itself. So I'm going to go minus 21, because 21 is added to the y, minus 21. So I have here plus 21 minus 21 is 0. So y plus 0 is simply y. Oh, y. 7 minus 21 is going to be negative 14. So I am going to draw my number line extending in infinity in both directions. And my important number here is going to be negative 14. I'm going to have a solid dot this time because it's greater than or equal to negative 14. And I'm going to say, okay, y is greater than negative 14. So my y can be 0. Yep. My y can be 2,000. Oh, heck yes. But it can't equal negative 15. Okay, because negative 15 is less than negative 14. So I'm going to be going in this direction. Now, you're noticing that the example doesn't say solve and verify. Now, I just want to take a quick second to explain why it would be pretty hard. Because there are infinite values for our variables. We just said that x is less than 15, okay? But like, there is a very large number, actually an infinite number of numbers that will satisfy the solution. I can put in 14, I can put in 13.2, I can put in 3/4, I can put in like a crazy amount of numbers. I can even put pi. I can say x, would pi satisfy it? Yeah, because pi is approximately 3.1415, going on forever. So yes, pi would even satisfy this. If I would say x equals pi, it would satisfy it. So to verify, we would have to verify every single possible number. That's impossible. And so we're just, we don't need to verify with, when the solutions are, when we're dealing with inequalities rather than equations.